All right, so today we're talking about patterns and linear functions. So what is a linear function and how can you identify them from a pattern? So the warm up here is look at this table and try and figure out how many people can sit at each one of these tables. All right, so we go through this, we can have an extra person sitting right there. We can have two more people sitting on this end. So this first table, with one table, we can have six people sitting here. We have two, if we keep going around, we can add one, 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 and two. Add that up, we get 8. Do the same process here, we'll get 10. So think of, well, now if we have 5 tables, what's going on? What are we doing each time? Well, we added 2 to get 8. We add 2 to get 10. So if we add 2 more, we'll get 12 for 4 tables, and add 2 more, we'll get 14 for 5 tables. So if we write that out and then graph it, we had 1, 2, 3, 4, 5 tables with 6, 8, 10, 12, and 14 people at each table. So we're going to write those in ordered pairs. What an ordered pair means is just listing two things in parentheses. So like 1, 6. Here, the 1 came from there, and the 6 comes from right here. We normally label these X and Y, so this would be your X coordinate and your Y coordinate. So this column is X, this column is Y. So if I write the rest in, we have 2, 8, 3, 10, 4, 12, and 5, 14. And then we can just plot these points. So to plot a point, we want to go on the X is always this horizontal, Y is always the vertical. So X is 1, and then Y is 6. So 2, 4, 6, and that's our first point. Then you can go to 2 to 8, 3 is at 10, 4 goes up to 12, and 5 goes up to 14. And this is our graph. So if we try and think of a pattern here, we can look back at our table. So we're going up by 2 each time. So this kind of goes back to chapter 1 when we found patterns. We're going up by 2 each time. So if we think of this, if we think of how many times we've gone up, here we've gone up by 1, 2. Here we've gone up by 2 2s, 3 2s, 4 2s. So if I think of this, I can do 2 times 2 plus 4 times 2 plus 4. So we think of this, we got to start with our X number times something, so times 2. So 2 plus 4 is 6, so that's how we get the first one. And then we want to add another 2 to that, so multiply by 2 again. And this would be our pattern continuing up. So writing that out in words, so our independent variable, our X, was at the bottom. So down here, this was our number of tables if we label our graph. And then here we had number of people on the Y. So our independent is number of tables. Our dependent would be our number of people. So every time our independent variable, or our tables, increases by 1, the dependent, or the number of people, increased by 2. So if we write our equation, if we had 0 tables, I mean, this doesn't really make sense, but if we had 0 tables, we started with the 4. And then every time our X goes up, we go up by 2. And we start with 4. So when you plug in 1, you want to get 6. So if I plug in 1, we do 2 times 1 plus 4 equals 6. That works every time after that you go up by 2. And that's your equation. All right, so what is a linear function? A function in general is some sort of relationship between two things where you have exactly one output. So you start with something you put in, some sort of thing. So here we're starting with tables. Your output would then be your number of people. So like you can't have one table seat up to 6 people and also up to 8, because that would have to be 2 different sizes of tables. That doesn't make sense. So it needs to be every time you start with one thing, you get only one thing back out. The coordinate pairs of a function are, so if the coordinate pairs of a function, so the coordinate pairs are our x, y, form a non-vertical line, then it's a linear function. So linear function means a line function. You're gonna have something that looks like this, or like this. So you just can't have a straight up and down line if you're gonna be linear. Okay, so another example. You have 12,000 megabytes of data to use every month. Every hour you spend on the internet uses 500 megabytes. So we want to create a table, graph, and equation of this situation. So let's start off. If we have 0 hours of data, we've done nothing. Well, then we still have our initial 1200 megabytes. We write that in our ordered pair. We have 0, 1200. So then I'm just going to go up 1 megabyte at a time. You could go up by half megabytes, or sorry, 1 hour at a time. You could go up by half hours if you wanted to. It's up to you. So in every hour, I'm using 500. So I need to subtract from this. So I'd have 11,500, 11,000, 10,500, 10,000 as we keep going down. And then your ordered pairs would be 1, 11,500, 2, 10,000, 11,000. And you need the parentheses or it's not an ordered pair here. And then 10,500 for 10,000. And now we can plot these points. So at 0, we're going to go up to 12,000. So there's 10. This would be 2, 4, 6. Sorry, 1, 2, 3, 4, 5. So we're counting it by ones. So there's our 0, 12,000. And then at 1, we're at 1150, so we're halfway in between. And then we keep going down like this if you follow the same pattern. And there's our graph. So now if we're thinking of a pattern, we have some sort of y equals, and then we start with something. We're starting with our 12,000, and then we're always going down by 500. And that number of times we subtract 500 is the same as our number of hours right here, or our x. So then how do we decide if a function is linear? So deciding here, is our function linear? So think of what's the pattern first. So we're looking at this, we have 1, 2, 3 up here, and then we're going up. We want to figure out how much are we going up each time. So 11 minus 6 is 5, so we're going up by 5. 16 minus 11 is 5. 21 minus 16 is 5. So each time we're going up by 5. So anytime the independent variable increases by 1, the dependent variable increases by 5. So we have this constant rate going up at the same time. So how can we describe this with words? So the value of y is 6 more than 5 times the value of x. So if we start at 0, y is 6 more than 0, so that works. We're at 11, we're 6 more than 5 times 1, so we're 6 more than 5. I'm going to keep going up like that. So if we write this out, you have 5x plus 6, because we start at 6, and then our change is 5. So you try this one, and then we'll talk about it. Okay, same idea here. We want to figure out the pattern. So if I go up by 1, then we're going up by 7, etc. So we're going up by 7 when we increase by 1. So now we have to figure out the pattern. So since this doesn't have a 0, a good idea is to then make the 0 in your table to help you write your equation. So if I write 0 up here, and we added 7, and we added 7, we have to subtract 7 to go this way. So we'd get negative 5. So we start at negative 5, and then we're adding 7 each time. So the value of y is 5 less, because we have negative 5 right here, than 7 times the value of x. So we want y 7x minus 5. This, like what you're going up, corresponds to here. And then what you're equal to when you have 0 is what goes right there. So that's it for 4.2. So go on Math Excel and do the 4.2 assignment.